Okay, the next concept I want to cover are flood guards and loop protection, and this is going to ensure availability of the network. Okay, previously we talked about securing physical access to the network. Now we want to make sure that that network is actually available for someone to securely access. So, by ensuring availability via flood guards and loop protection, we have a couple concepts that we want to talk about. Loop protection in a layer 3 context. Remember now, layer 3 deals with IP and with routing with network. Okay, it's the network layer of the OSI model, and routers live at this layer. All right, so layer 3 deals with routing IP packets across the network. And as IP packets travel, every time they cross over a router or every time they have a hop, they decrement with something, or what's called rather a TTL, or a time to live. So an IP packet has a finite lifespan, or a time to live on that network. If it lives too long, the packet gets dropped. In other words, if it doesn't reach its destination in a certain amount of time or a certain number of hops, it gets dropped. And that's specifically to prevent packets from just endlessly looping around the network. All right, so each router hop decrements the TTL, and then the packet is dropped once that TTL expires. So when you see, as you see in this example here, we have a couple networks separated by some routers, and in a normal fashion, the packet would traverse the routers. Okay, the router knows how to get from point A to point B, and the packet goes from one network to the other. Okay, all is well with the world, right? In a misconfigured situation, we'd have that packet just traverse and loop. Okay, so if the routers aren't configured properly and they don't know exactly where to send the packet, router A thinks it should go here, B thinks it should go somewhere else, C thinks it should go back to router A's path. You'll get a looping scenario, and if you didn't have that TTL in place, that packet would just loop endlessly forever. And then as the next packet were to come on board, and the next and the next and the next, you can imagine very quickly that network would get overrun. So by having that TTL in place, we negate that scenario from occurring. Now in the layer 2 space, we don't have that TTL benefit. Okay, we don't have that ability to decrement. Layer 2 deals with switches, bridges, things along those lines. All right, layer 2 of the OSI model. So in layer 2 parlance, we have spanning tree protocol. Okay, so it accomplishes the same thing as far as loop protection, just does it in a different fashion. So in this example, we have two switches. We have information that obviously needs to pass from point A to point B. But if we have switches, which are basically multi-port bridges, and information comes in one port, goes out the other, if the switch doesn't know exactly which port to send it out of, you can get, as you can see, if it were to go in switch A or out switch A's FA 0/1 to switch B, and then it send it back out 2 to 2, you can see how it would just loop endlessly. So what happens is we have an election that takes place. The root bridge, it gets elected. The root bridge is the center of that network. The designated bridges, or the designated bridge, are forwarders that send data to the root bridge. And then the root port is the port that sends data toward the root bridge. And if we didn't have the ability to shut down the non-necessary ports, we would just get loops all over the place. Now, it doesn't mean those other paths aren't available. It just means they're not active. So if we have a failover situation where that path becomes inactive or fails, the switches would then fail over and activate those other ports. It might take a few seconds, 15 to 20 seconds potentially, for all of that to kind of synchronize and go through its process until those other paths come up. But the network would basically kind of heal itself. All right. But at any one point in time, we only really want one path from point A to point B. Now, incidentally, root bridges are designated by the lowest MAC address typically. All right. And as you can imagine, right, the lowest MAC address is going to be more than likely the oldest device on your network. So you don't want to necessarily let the automatic process take place and allow that root bridge to be elected automatically, because it's more than likely going to be the oldest device and maybe have the least capability, right? So by manually selecting the root bridge, you can pick perhaps a much more beefy switch or a newer piece of equipment, so that way you can ensure just a higher level of stability for the network.